This video is going to review sigma notation. If you feel really confident and polished on it, you can skip it. But if you don't feel as comfortable or if you need to come back later, feel free to review with this. So sigma notation is used to summarize addition. So if you're adding a bunch of related numbers, sigma notation is used to summarize that. So, or the sum of related numbers. Technically, they don't have to be related, but if they are related, that's where we tend to use it more because it actually lets us work with it. So the general form, I'm just going to put this up so I know how much room I have. The general form is something that looks like this. That should be a little n. So let's do this. So this is the upper bound of index. This is the initial index value. This is what we call the general term. And sorry, that should be an I. Let me fix that. I always slip up on that when I'm writing this general term. So that should be, like I said, an I. Because that I right there is the index. So you'll notice what happens is we just write each term, but wherever there's an I, we replace it with whatever index we're on. So first we replace it with a 1, then a 2, then there'd be a 3, etc., all the way until we get to n, which is your upper index bound here. So as an example, if we have starting at I equals 0, going up to 5, with 2i squared, we can just write 2 times 0 squared plus 2 times 1 squared plus 2 times 2 squared plus 2 times 3 squared plus 2 times 4 squared plus 2 times 5 squared, which will end up giving us a grand total of, I believe, 110. As you can see how all that we did was we just wrote the same term over and over and over and over again until we got to our final index. So some miscellaneous notes. Sums will usually start with I equals 0 or I equals 1, but you can use any value. It's just 0 and 1 tend to be easiest and make the most sense for whatever you're working on. N can be any value including infinity. So in the past, we've said that technically we can't put infinity, we can't put infinity into a function, but we can, say the limit as n approaches infinity, etc. You can put an infinity into, well, again, technically we can't put it in, but we can say the limit as n approaches infinity, so it's true enough that we can plug that in there. But you get the kind of idea that we can go from one value all the way up to any value we choose, including infinity.